Right, so this one is I can use centers of triangles to model and solve problems. So we're going to use some vocabulary from previous math courses, and then I'm going to teach you some new vocabulary, and then I'll show you some problems, and hopefully it makes sense. Alright, so here's the 4 vocabulary terms that you should remember, but in case you don't, we'll talk about them. So number 1, altitude. The second one is median. The third one is angle bisector, and the fourth one is perpendicular bisector. So let's look at these. So an altitude is this line right here. It's sometimes referred to as the height of the triangle. It's going to go from a vertex, so here's the vertex, over to the other side, and it's going to make a 90-degree angle. So that's what you should remember about an altitude. Alright, look at the next one, median. That's this one right here. A median is going to go from the vertex, so the top of the triangle, to the opposite midpoint. So if you'll notice, it has the little tick marks on here, but in case you have forgotten what that means that these two pieces over here are congruent to each other. So that's what you should remember about that. The next one is your angle bisector. So an angle bisector, it bisects an angle. So it makes two congruent angles, which is what these little tick marks mean. Yeah, that's pretty easy. And then perpendicular bisector, people get this one confused more often than not. So it doesn't come from a vertex. It's the only one out of these 4. And it just has to make a 90-degree angle, so that's a little box right here, and it has to split the side into 2 equal pieces. So it's kind of like putting the altitude and the median together, but you're not coming from a vertex. So hopefully that jogged your memory. If not, you can find plenty of Khan Academy videos, or just search in YouTube if you need some more information. So here are the 4 that you need to know for Math 3. And you need to understand what these are called, how to find them in a picture, and then how to use them to solve problems. So, number 1, orthocenter. Number 2, centroid. Number 3, incenter. And number 4, I just noticed, that must be... Okay, so the spell check got me. That's actually circumcenter. And if you ever type this in, it is going to flag it because it doesn't think it's an actual word, but it is a math term, I promise. I did not make it up. Okay, so let's talk about this. So the first one is orthocenter. The orthocenter is right here, and it's the center of all 3 altitudes meet. So that's why you had to know what an altitude was, because you have 3 of them in this picture. So the altitude is going from the vertex to the opposite side, and it's making a 90-degree angle. So the place where all 3 of them meet is called the orthocenter. Centroid is our next one. The centroid is going to be right here. The centroid is where all 3 medians meet. And then this is very important to remember. The centroid is 2/3 the distance from the vertex to the opposite side. So here's the centroid. Right here. This would be 2/3 of the entire length. So that would make this side 1/3 of the entire length. So let's say the whole median was 9. This part over here would have to be 6 because 2/3 of 9 is 6. And then this side would have to be 3 because 1/3 of 9 is 3. And then if you add 6 and 3, you get 9. So, whichever one looks like it's the longest side, that's your 2/3 length. And then the one that looks smaller is your 1/3 length. So you can trust the picture in this case. Alright, incenter. So the incenter is going to be right here, and it is where all 3 angle bisectors meet. And the thing you have to remember is the incenter is equidistant from the sides of the triangle. So all 3 of these would be equal, but then also like these things are going to be equal over here. So it's something like that. That was horrible how I labeled it, but if it looks like it's equal to each other, then that's what you should know about it. And then the last one is circumcenter. So be careful when you're saying this one out loud because sometimes people say other words. But a circumcenter is where all three perpendicular bisectors meet. And then the circumcenter is equidistant from the vertices. So not too bad. You can see on the picture how it's labeled. These two sides are equal. These two are equal. And then these three are equal. So that's what that means. So that's really confusing. So that's why we have this little sentence to help us remember which ones are talking about each other. So if you'll remember this sentence, all of my children are bringing in peanut butter cookies. You have to remember this because here's what it means. I have no idea why this one's way over here. When you say all of, that means where all three altitudes meet, that's called your orthocenter. When you say my children, all three medians meet at the centroid. When you say are bringing in, all three angle bisectors meet at the incenter. And then the last one, when you say peanut butter cookies, that stands for perpendicular bisectors. They all three meet at the circumcenter. So that's just a little sentence to help you remember that three altitudes become the orthocenter, three medians become the centroid, three angle bisectors become the incenter, and then three perpendicular bisectors become the circumcenter. So here's a problem that we're going to do together. So if F is the circumcenter of triangle JKL, we want to find FE. So FE is this little space right here. And so it gets a little confusing because you're like, where do I even start? So you have to remember that the circumcenter is where the perpendicular bisectors meet. So that means that FE is a perpendicular bisector, which means it's making a right angle, but it also means that it's making two equal pieces. So when you look at this, the whole thing is 52, so just one of those pieces would be 26 and 26, because 52 divided by 2 is 26. Alright, and then here's the other thing, and you can even see all three of those are equal to each other. So what I'm going to do is I'm just going to draw 27 over here. So do you see what shape that just made? That just made a right triangle. So I got 27 from the green part. I got 26 from the blue part. And I want to find this other side, which is my F to E. And so how do you find a missing side of a right triangle? Use Pythagorean theorem. So I'm going to call this side A, this side B, and this side C. And Pythagorean theorem states a squared plus b squared must be equal to c squared. So we don't know what a is. That's what we're trying to find. We know that b is 26. And we know that c, the hypotenuse, is 27. And we know that that's the hypotenuse because it's across from the right angle. Your biggest side is always there. Okay, so now I'm going to go ahead and simplify. I'm going to square 26 and 27. So I just rewrote the problem. And now I'm going to move that 676 to the other side by subtracting. So I'm going to do that really quickly. And I get 103. And then the way you get rid of a square is to square root it. So I'm going to take the square root of 103. And I'm going to round to one decimal place. So I get 10.1. So the only math that was involved was from middle school, the Pythagorean theorem. And then all I had to know was what a circumcenter was and what to do with it. So let's do this one. Once again, talking about the circumcenter. So we know that we got some, oh goodness, we got some perpendicular bisectors going on. Let me move that back over. We're trying to find QP. So I'm going to find that on my paper. Alright. So if you'll notice, do you see all three of these lines that are coming from the vertex? All of those are equal to each other because they're all pretty much the same thing. So this side right here and this side right here are both equal. So what we're going to do is set them equal to each other. Alright, so I'm going to get the x's on one side. I'm going to move this x over. And some of you can do this without showing all the work. Good for you. If you need to write out all the steps, then do it. Nothing wrong. And then I'm going to divide both sides by 4. So x equals 33.3. I'm just kidding, 33.5. Okay, sorry, my son just came in the room and it distracted me. Okay, so if this is 33, then this side is also 33. So let me clean this up a little bit. Let me get rid of this. Alright, I know that this is 33.5. I'm trying to find that little red piece. So if I were to redraw this triangle, I have a right triangle, I have 33 over here, I have 33.5, and I'm trying to find this side QP. So once again, I'm going to use the Pythagorean theorem to figure out what QP is. And make sure that when you do this, you're going to do a squared plus b squared and make sure it equals c squared, the one across from the right angle. So some people set it up incorrectly. Alright, I'm going to let you try this one because I think you can do it. So I'm going to pause the video. Alright, so I got a was equal to 5.8. So if that didn't make sense, go watch videos on finding the Pythagorean theorem. Okay, let's try one more. I want you to try this one by yourself, so I want you to pause the video in the next 3 seconds. 1, 2, 3. Okay, so let's see if you got this correct. So you were looking for this entire side GH because it says find GH. Okay, the other thing is notice that both of these are coming from the vertex, so they're both equal to each other. I'm going to set them equal to each other and solve for x. And I got x equals 4. Now I'm going to plug it back in just to one of the sides and see what it actually equals. And so one side is 37, the other one's 37. It doesn't really matter which one you plug it into. So you should notice that you have a right triangle. And what are you going to do? Pythagorean theorem. So set up Pythagorean theorem and solve. Okay, and then hopefully you realize that 35 is just this part over here. And the problem actually asks for GH, which is the whole thing. So you have to add 35 and 35. So your final answer is going to be 70. So if you did that, great job. If not, maybe you should rewatch the video, find some other videos, or email me for questions. Okay, so here's a meme for all my math nerds out there. Relax, breathe, you're at the end of the video. Email me if you have questions. We'll work it out together. Bye.